Hello, my name is Peter Travers and I'm the CEO of LB1000. In this video, we will show you our ability to dynamically control tumor treating fields to any configuration. Then we will show you our device in use. Last, we will show you a 3D simulation of an identical field and then give a brief explanation of the advantages of our device. Let's get started. This is a graphic showing how tumor treating fields work through the human body. The lights blinking on the patient indicate that a field is passing through the body from the red disc to the green, killing cancer cells. This sequence repeats the previous switching, but at a faster pace. Research shows faster switching can increase tumor reduction. Now we create a tumor treating field wave through the body. This would be beneficial for diffuse disease. Here we show a half-moon field showing that any array element can switch to the opposite polarity. Here we show a full tumor treating field utilizing all the discs in the arrays. Our goal with this next shot is to show you one continuous scene with our tumor treating field device working, putting fields through my body. The arrays are now on my body, one in the front and one in the back. As you watch the device working, we believe you're watching medical history. We know of no other device that can place a fully controllable tumor treating field through a human body. The international patent examiners agree with this statement as they awarded us a patent priority date in over 140 countries, indicating they found no other device like it in prior art. We are now patent pending for long-term protection in 37 countries. The first country to finish examining our patent application was Luxembourg, who has awarded us a full 20-year patent. These arrays could be increased by 12 discs and would be large enough to treat lung cancer. A second could be added and it would be large enough to treat liver cancer from front to back and side to side. As we round to the front, you will see a half-moon field firing, which shows that each element can cross over to the opposite polarity, creating the possibility of any firing configuration. Now we are going to head down to the oscilloscope. On the way you will see the amp meter attached to the arrays. The images on the oscilloscope document that there is an electric field traveling through my body. The sine waves you see on the screen would not be there if the field was not coupling or forming through my body. The last sine wave you are going to see on the screen is of all 8 discs firing. The intensity, frequency, and voltage of the sine wave are within the parameters described in the FDA submission documents for fixed array tumor treating fields to treat lung cancer. Now let's move to 3D simulations using the Sim4Life medical simulator. Sim4Life is a revolutionary simulation platform combining computable human phantoms or models with the most powerful physics solvers and advanced tissue models. This allows the analyzing of biological real-world phenomena within the human body. This is a CAT scan from a female with metastatic breast cancer in the lungs. An individual patient's scan is imported into Sim4Life. This allows us to target the diseased area and personalize the treatment. Additional FDA approval is needed for Sim4Life to be used in this way in the United States. The models contain over 140 tissue types, each with its own dielectric constant. This is another way of saying that Sim4Life understands and can visually represent what happens to an electric field when it goes through the human body. Here we are asking Sim4Life to take images and slices much the way an MRI does. This will give us a visual representation of what the field that was going through my body would look like going through the lungs. Now we are going to change our perspective by looking at one of the visual image slices from the top down. We remove the outer skin layer to isolate the lungs. This allows us to pay close attention to the tumor treating field represented by the color mapping through the body. Now we are going to remove the image of the lungs from the screen so that we can get a better view of what the tumor treating field is doing through the body. Before we do that, I've outlined the lungs so that we can maintain their orientation during our discussion. As you can see, the tumor treating field is moving right back to left front in this particular view, and you can clearly see there's a stronger, more therapeutic portion to the tumor treating field through the center of the arrays, represented by the white colors being the strongest, the yellow the second strongest, etc. The effectiveness of tumor treating fields can be shown on a graph. Here on the y-axis, we are illustrating the rate of growth of a tumor. On the x-axis, we are representing the intensity of the tumor treating field in volts per centimeter. When you introduce a tumor treating field at the rate of 1 to 1.5 volts per centimeter, the rate of tumor growth drops by 20%. However, the important thing to realize here is that even at this level, there are more tumor cells growing than are being killed. When you increase the intensity to 1.75 volts per centimeter, the rate of tumor growth drops by 35%. It is not until the intensity of the tumor treating field gets to 2 volts per centimeter that the tumor growth rate drops below 50%. It is at this level that more cells are being killed by the tumor treating field than are able to grow. At this level of intensity, the tumor will eventually be eliminated. But look what happens when the intensity of the tumor treating field is raised to between 2.5 and 3 volts per centimeter. The rate of tumor growth is reduced by 80%. What if you could control this most therapeutic portion of the tumor treating field and make sure the broadest possible tumor reduction takes place? This is exactly what the LB1000 device is designed from the ground up to accomplish. To illustrate this point, here is the image of the tumor treating field we showed earlier. The most therapeutic portion of the field is obvious through the middle of the tumor treating field arrays. However, the portion of the lung we just highlighted in green is not getting a therapeutic field. The goal of fixed array tumor treating fields is to make up for these weak areas through additional targeted firings. Here we show a firing left back to right front. When we highlight the undertreated portions of the lung from the previous firing, we can see that much of the area is now covered with a therapeutic field. However, these areas do not receive a therapeutic field in either firing. Even fixed firing configurations that can deliver a therapeutic field to almost all the lung still fail to deliver the most therapeutic portion of the tumor treating field to as much as 30 to 40% of the lungs. For millions of patients, this does not matter. They have isolated tumors and targeted delivery serves them very well. However, there are also millions who have diffuse disease that need a more comprehensive solution. Our device, called the LB1000, offers that more comprehensive solution. By controlling the most therapeutic portion of the field, we can distribute it over a broad diseased area, offering more tumor reduction. Research shows that if you disrupt cell division using a tumor treating field and then leave for a short moment and return, the cancer cells do not have time to recover. In other words, exposing a dividing cancer cell to a tumor treating field in short intervals has the same killing power as a constant field. An even more serious drawback to fixed tumor treating field arrays is when late stage disease begins spreading in multiple locations. Eventually you will run out of room to create targeted firings because you cannot put arrays on top of arrays. The LB1000 device overcomes this problem through its ability to dynamically assign array elements to any firing. Here, in the span of less than 1 second, the discs highlighted in blue were used for the liver, left lung, and peritoneal cavity. On behalf of those who have more life to live, we would like to ask you to join our team by investing in our effort. Our company is set up as a social enterprise. All investors must agree to give a percentage of profits to those who cannot afford treatment, and discounts are given to lower income families. Please start by following us on Facebook. Visit our website at lifebridge10000.com. And finally, find out about our investment opportunity on wefunder.com. We would like to thank the following companies for supporting our efforts to build our prototype: Apex Microtechnology for supplying us with vital parts, Zurich MedTech, makers of Sim for Life. Thank you for your time on behalf of those who have more life to live.